In this video, I want to look at some more difficult examples of using the general binomial expansion. And in particular, I want to focus on the fact that in both of these examples here, this number here that I'm underlining in red is not equal to 1. And notice in our general binomial expansion theorem, which we have in the blue box here, we always had a 1 plus. So it relied on the fact that this number here was a 1. And these two things here I'm asking you to find the binomial expansion of. They haven't got a 1 there. So we've got to be very careful about how we deal with this. So we can't do anything until we get a 1 in that place. So we need to, what can we do with these to get a 1 in the right place? So let's take this first example. 3 plus x to the power of negative 4. And let's think, okay, how could I get a 1 in the bracket? Well, what I could do is, inside this bracket, I could take a factor of 3. And I remember taking a factor of 3 of the whole thing. So if you think carefully, these two expressions are equal. Because if I expand this out, I get 3 times 1, which is 3, and I get 3 times x over 3, which is x. Well, okay, that's useful because we've got a 1, but let's think about what this is equal to. This is equal to 3 to the minus 4, lots of 1 plus x over 3 to the minus 4. Well, this is good because this is something we can now use our binomial theorem to expand. But we need to remember we then need to multiply our final answer by 3 to the minus 4. Or 3 to the minus 4 is 1 over 81. So this is 1 over 81, lots of the binomial expansion of 1 plus x over 3 to the minus 4. Well, let's go ahead and do this. This is equal to 1 over 81. And it might actually be more useful to write this as 3 to the power of 4. Because hopefully some factors will start cancelling. So 1 over 3 to the power of 4, lots of 1 plus nx. Well, n is minus 4. And in place of x, we have x over 3. So minus 4, lots of x over 3. Then n, so minus 4, n minus 1 minus 5 over 2 factorial, lots of x over 3 squared, and then minus 4 minus 5 minus 6 over 3 factorial, lots of x over 3 cubed, plus our remaining terms. So that is our binomial expansion, but we want to do a little bit of work on that to get that simplified. So I'm going to leave my factor of 1 over 3 to the power of 4. This is 1 minus 4 over 3x. And then here we have a positive, because the two negative multiply to make a positive. 4 times 5 times a half times 1 over 3 squared, lots of x squared. And then here we have a negative, because we have 3 negatives being multiplied. So 4 times 5 times 6 times 1 over 3 to the factorial, so 1 over 3 times 2 times 1 over 3 cubed, x cubed, plus our remaining terms. And now let's simplify this. We get 1 minus 4 over 3 lots of x. We have nothing at cancel. We have a factor of 2 cancelling with the 4. So we have 10 over 9 lots of x squared. Here we have the 6 cancelling with this 6 here. So we have 20 over 27 x cubed. And that is probably a good enough answer. If you want to expand that out, or you want to write that as 1 over 81, that is absolutely fine. But we also need to be very careful and ask when is this valid? Well, the question of validity comes in when we ask about binomial expansion. So we're really asking is when is this valid? Well, this is valid when x over 3 is between -1 and 1, which is equivalent to, say, x between -3 and 3. So this is valid when x is between -3 and 3. Now let's look at the second example. And this looks a lot more complicated, but again, it's the same idea. We need to get something that looks like 1 plus x to the power of n. So if we have our 1 over the square root of 4 minus 3x, this is equal to 1 over 4 minus 3x to the half, which is 4 minus 3x to the negative a half. So we're getting there. We have a value of n that looks like it's going to be negative a half, but we still haven't got a 1 here. So what do? Well, we take that factor of 4 inside that bracket. So we take a factor of 4, 1 minus 3/4 of x, close that bracket and close this bracket, all to the power of minus a half. Well, what is that equal to? Well, that is 4 to the minus a half, lots of 1 minus 3/4 of x to the minus a half. Well, actually, 4 to the minus a half is something we can find. 4 to the minus a half is a half, because it's 1 over the square root of 4. So this is just a half of 1 minus 3/4 of x to the minus a half. And now this is something we can use the binomial theorem on, because it's in the form 1 plus something. But what do we have? We have n is equal to negative a half. And we have, instead of x, we're using minus 3/4 of x. So what is this equal to? Well, it's equal to a half of 1 plus nx. So 1 plus minus a half of minus 3/4 x plus n, so minus a half, n minus 1, which is minus 3/2 over 2 factorial lots of minus 3/4 of x all squared plus minus a half minus 3/2 minus 5/2 over 3 factorial lots of minus 3/4 of x all cubed plus our remaining terms. So this is quite fiddly because there's lots of different numbers here, so we need to be very careful about simplifying this. So what is this equal to? Well, it's a half of 1 plus 3/8 of x. So what have we got here? We've got 4 negatives all being multiplied, so that is positive. We have a half times 3/2 times a half, which is the 1 over 2 factorial, times by negative 3/4 squared, so 3 squared over 4 squared, lots of x squared. Here we actually have 6 negatives being multiplied, so this is going to be positive, and we have a half times 3/2 times 5/2 times 1 over 3 factorial, which is 1 over 3 times 2, times 3 cubed over 4 cubed, lots of x cubed. Well, let's see if we've got any factors we can cancel. We have a half of 1 plus 3/8 of x. Here, are there any factors that cancel? There aren't actually any factors that cancel. So what have we got here? We have 27, and then we have 128 x squared, And then here we have a few factors that will cancel. We have a 3 that cancels with one of these 3's. So we have 27 times 5, which is 135, over 16 times 16 times 4. 16 is 1024, x cubed, plus those remaining terms. And if we expand out that half, we get a half plus 3/16 of x plus 27 over 256 x squared plus 135 over 2048 x cubed. And when is this valid? Well, this binomial expansion is valid when minus 3/4 of x is between -1 and 1. So minus 3/4 of x is between -1 and 1. Well, multiplying by 4 and dividing by 3, this gives us x is between -4/3 and +4/3.